Assalamu alaikum viewers. How are you all? Hope you will be fine. I am Engineer Shaidanam here with you. Today our topic is resistances in parallel. In previous lecture we have discussed the resistances in series. Now we will discuss the resistance in parallel, and in next video inshallah we will discuss the simulation of resistances in parallel. You will observe it in circuit. These are some resistors connected in parallel, because in parallel each resistor is connected with another resistor at 2 points. So three resistors are connected here in parallel with a power supply, that is a DC supply. These are some resistors in front of you. This is how practically the resistance looks like. According to Ohm's law, we know that V is equal to IR and I is equal to V divided by R from the above equation. And if we have to calculate the current, if we calculate the current through R1, then the equation will be like I1 is equal to V divided by R1 and I2 is equal to V divided by R2. Here I1 uh, is equal to V divided by R1. R1 and R2 changes, but V remains the same, because we know that in parallel circuit the voltage across each resistance will be the same and the current will divide. But remember one point, that on load side the current divides, whereas if we talk about the generation side, then the current will get aired. Now if we connect two resistances in parallel and want to find the current, the total current, then the total current will be I is equal to I1 plus I2, putting the values of I1 and I2, that was I1 is equal to V divided by R1, I2 is equal to V divided by R2, putting these in this equation. So we will get V divided by R is equal to V divided by R1 plus V divided by R2. Taking V common, we will get V divided by R is equal to V into 1 over R1 plus 1 over R2. And the V will be cancelled out with the V on the other side of the equation, and the final equation will be I divided by R, sorry, 1 divided by R is equal to 1 over R1 plus 1 over R2. This will be our final equation. Now what does this equation mean? This equation means that the total resistance now in parallel will be equal to or will be less than the individual, the lowest individual resistance. Now the conclusion is the total resistance is less than the lowest value of individual resistor. So it is clear from here that when we add resistances, or when we connect lamps or any appliance in parallel, then the voltage through each appliance, the voltage across each appliance will be the same, and the current through each will be different. So and in parallel, the total resistance or the total opposition to the flow of current will be less than the individual lowest resistor. Thank you, and remember to subscribe the channel for more informative video.